All right, guys, thank you. It's a lot of materials for 4 minutes, so I'm going to talk quick. Forgive me if you miss anything. We'll be here for questions afterwards. What Liqid focuses on is something referred to as composable infrastructure. Composable infrastructure is the next generation of how we're going to build servers inside the data center. Normally with servers, the way that we build them is we take peripheries and we plug them into the sockets of the motherboard. With composable, we take a different approach. It's about taking trays or pools of resources. Imagine a tray of CPUs, a tray of GPUs, a tray of SSDs, and a tray of networking devices. And rather than plugging them into a motherboard, we plug them into a PCIe Fabric switch. And then we come in with software and we orchestrate or we compose the server with whatever amount of resources that you want. Grab this CPU, grab those 4 SSDs, grab these 12 GPUs, those 2 network devices, and config or orchestrate for me a physical bare metal server. Just like you were plugging stuff into the socket of the motherboard, except you're defining it in software, and on the other side, you're getting delivered a physical bare metal machine. What Liqid produces is that fabric that interconnects these pools of resources and the software that allows you to orchestrate these physical machines. The fabric that we've chosen, I'm not sure why it's showing like this, but the fabric that we've chosen to interconnect our pools of resources is PCIe. For the first time in the data center, we're on a common bus. Compute always had PCIe coming in and out, thank you. Networking cards, where are they deployed? PCIe bus. GPUs are relevant in the data center, where do they go? They also go onto the PCIe bus, and now that storage has migrated to NVMe, it's the first time in the data center that all the peripherals in the data center are on a common interconnect, which is PCIe. That's why we've chosen our fabric to be PCIe, so we can interconnect these things and orchestrate at the physical bare metal as opposed to doing electrical translation, protocol translation, or virtualization. What we build is that switch and the software that lives inside the switch, and to this switch you connect off-the-shelf pools of storage, compute, networking, and GPUs. Then you come in as an administrator and you say, okay, I would like to compose my machine. Grab any amount of physical resource that you want, configure the machine how you want it, and then set the policies in place to say, okay, when my server goes above 80% storage used, automatically reprogram the fabric, give me more storage. At 10 o'clock at night, when I know no one is using those GPUs, take them apart, put them in a general pool so someone can run some batch files on. It's all about getting maximum resource utilization out of the gear that you're deploying in your data center. We believe the world is going to be composable. The idea of deploying a static server in your data center and hoping that that fits your workload for the next 3 to 5 years, in the days of AWS and Microsoft, those are gone. People want dynamic infrastructure. They want to be able to orchestrate the machine to best match the application that they're looking to deploy. We have one customer who's looking to put together a GPU supercluster. So inside of a single rack, they deploy 60 GPUs, 12 CPUs, 12 networking devices, 36 SSDs, and they come in and they dynamically orchestrate the server for the workload that they're trying to accomplish. If they need a server with 2 GPUs, great, spin that up, orchestrate it, use it for however long you want, and then release the resources back into the general pool as soon as you're free. This is how you get 100% utilization out of the gear that you're deploying in your data center. And also it solves problems specifically around GPU for things like GPU scale out. I can buy a server that has 4 GPUs. I could even buy one that has 8. What if I need 16? What if I need 32? How do you scale out these GPUs to massively large clusters for HPC environments? We believe a composable fabric is the kind of way to get there. This is a hardware stack that we deploy. On the very top, you see that's a box of networking cards. Below that is a box of storage. Below that is a box of GPUs, and below that are a bunch of x86 servers. Those could be 1U, they could be 2U, they could be blade servers. What we do is we come in with software and we compose resources to those machines. Even though that's a 1U server, I can come in and give him 4 SSDs, 2 GPUs, and 12 network cards, and I can do it dynamically. So that's my time, guys. That's the 4 minutes, so appreciate it.